Hello friends, yesterday we have seen the basics of finite element analysis and what are the advantages, applications, and what are different steps involved in the finite element analysis. So now today we will see what are the basic steps in the finite element method in time independent problems. Okay, so first one that we have seen already, that is domain discretization. That is what we can say, we can see it as a meshing also. So then select element type in approximation and shift. So derive element equation, variable and energy method, then assemble the element equation to form a global stiffness. And we have seen this equation which are given in red color, that is K is the stiffness matrix, into U is the displacement vector, and is equal to, then F is the force vector. So what you can say here, the next step is incorporate boundary and initial conditions. So we can give the initial boundary conditions to them, and we can solve this assembly of matrices, that is K, U and F, to form the simultaneous equations. There we can see many types of conditions, like we can have the penalty approach, or we can have the elimination approach as per the given conditions, because we know that at the fixed point we take the displacement as a 0, and at that point is the deflection is 0, so that we can have the multiplication factor to the stiffness matrix, that is equal to 0. So we can eliminate that particular line or that particular row and column of throughout the matrix, or what we can say, throughout the equation, and we can have the easiest solution with the help of eliminated uneliminated rows and columns. So we can solve this system of equations, simultaneous equation, for the deflection of given nodes at the given nodes, and stresses in each element, and also we can have the strain values with the help of that equations. So we will see now the what are some common sources of errors in FEA that we can observe in many situations. We already have stated that this method is approximation method, because it doesn't give you the exact solution, because here we have considered some that component in some arts, that is we have divided that whole domain in some finite number of elements, so that there may be a discretized form, there not be a continuous form. So element interpolation or approximation, that is also applied over here, because approximation we are using at many sections, and also we have integral numerical integral errors, because there may be some terms in integration also that we have to just neglect that one, because of simplicity in calculation, that may lead to the errors. So including spatial and time integration also. Okay, and computer errors are also considered, because any computer that will select, or that will round off some values after the dot place, because it is not possible to have exact solution up to 16, 20 or whatever it may be digits after the point. So we take a round of for up to 2, 3, 4 points after the point. So these are all the sources of error. Then measurement of accuracy, if you want to measure the accuracy of your finite element analysis problem, then you can find the error, that is the difference between the exact solution and the FEM solution. And also we can have the convergence limit of error, we can find it as equal to number of element or H convergence or approximation order, that is P convergence, that increases ideally error as number of element or approximation in order. Then two dimensional discretization refinement, what we can say, if you want to refine some part of this finite element analysis problem, then we can have the refinement in what we can say meshing, because if you have a circular hole in a plate and we are using this triangular element, then what will happen, that circular portion will not appear over here and it will lose its circularity because of this uh, high dimensional problems. What we can say, here we can see the element size is greater, so we can have the less or we can have the smaller size of element to have the exact round shape or exact shape of that element. It will give you the exact or better solution. So we can have also discretization. Here we can see in first diagram discretization with 2 to 8 elements, that will not give you the refined mesh, and after refinement we will have this 912 elements which will appears as a very good in meshing. So it is flexible meshing what we have used. So the size of element has used uh, according to the shape of the element, as at the center there is required the small elements, it has been used for that. So at the some distance away from this circle, there are coarse elements are used or higher size of element are used, because the stress concentration is at the center or at the circular portion. So so now one dimensional examples, so we can see bar element or beam element. For that elements also we can use the one dimensional equations, and this is the two dimensional equation, that is triangular element, that is scale valued two dimensional field problem, and vector or tensor valued two dimensional field problem, that is we can have the constant strain triangular element also, two dimensional elements. And here we can have these methods for finding the development of finite element equation. First one is direct method, then variational virtual work method, and weighted residual method. So we are having uh, the interest in direct method, so we will see that one in our next lecture. Thank you very much.